Hello, Math Masterminds. We are working with Pythagorean Theorem and its converse today. First example, which of the following could be the side lengths of a right triangle? Now, when we're working with this converse, we're going to be given all three dimensions of the triangle. We have to remember to use the longest side as the hypotenuse. So when we're substituting into our formula, a squared plus b squared equals c squared, we have to make sure that the longest side is always c, which represents the hypotenuse. Now, what we're asked to do with the converse is prove that a triangle is a right triangle. Because if the measurements work with the Pythagorean theorem and we can prove it to be a true statement, then it is a right triangle. So let's take a look. Let's substitute our values that's given into our formula. And we have 3 squared plus 5 squared equals 6 squared. When we solve it, we see that 34 does not equal 36. So therefore, those measurements will not create a right triangle. We will continue with answer choice B and C, working them the same way until we find the one answer choice that has the three measurements that will create a true statement, letting us know that it is a right triangle, and that will be answer choice D. Second example, which of the following cannot be the side lengths of a right triangle? We have to be careful here of the word cannot, okay? We're going to do the same thing. We're using a squared plus b squared equals c squared. We're making sure the longest length is substituted for the hypotenuse, which is represented by c. When we solve, we see that 25 equals 25, which means those measurements create a right triangle. So since I'm looking for the one that cannot, then answer choice A is eliminated. Okay. Now, I'm going to use something called the Pythagorean triple. Since I have identified that the side lengths 3, 4, and 5 create a right triangle, I can also use those measurements to help me identify other right triangles by its multiples. For example, 3 times 5 gives me 15. 4 times 5 gives me 20. 5 times 5 gives me 25. But here it says 30, which tells me that that measurement will not create a right triangle. Okay. Again, I can use these measurements because these numbers are multiples of what I have. So 3 times 2 gives me 6. 4 times 2 gives me 8. 5 times 2 equals 10, which tells me 6, 8, and 10 will create a right triangle. So that cannot be my answer. 3 times 6 is 18. 4 times 6 is 24. 5 times 6 is 30. So the measurements 18, 24, 30 will create a right triangle. And using the Pythagorean triples, I have proven that answer choice B will not create a right triangle. Okay? Well, I hope you understood those examples of using the Pythagorean theorem and its converse. If you still have difficulty, you can always press the help button that's in our virtual classroom in order to come see me on Google Meets during my office hours or teacher talk time. Look forward to seeing you.